Okay, in this video we want to find the inverse transform for the function fs is given as 2s minus 3 divided by s squared minus 2s plus 1. And so let's get started. And so first thing we're going to do is kind of rearrange what we have. If we say fs is equal to 2s minus 3 divided by, we can factor this out by saying s minus 1 times s minus 1, like this. And further, we can break down the numerator into something similar to s minus 1. And so that would be 2 times s minus 1. By doing that, we get 2s minus 2, and we have minus 3. So we say minus 1, so it's equivalent, divided by, instead of saying s minus 1 times s minus 1, we can just say s minus 1 squared is equal to, and the next thing we're going to do is kind of rearrange what we have. If we say 2 times s minus 1 divided by s minus 1 squared minus 1 times 1 divided by s minus 1 squared, like this. By doing it like this way, this term right here would cancel, and we would get 2 times 1 divided by s minus 1 minus 1 times 1 divided by s minus 1 squared. And the next thing that we're going to do is try to match this with our table. So 1 divided by s minus a would give us e raised to at. And so for us, our a term would therefore be 1 for this. Next we have negative 1 times 1 divided by s minus 1 squared. And this is very close to this term right here. N factorial divided by s minus a raised to n plus 1. And so if n is 1, n factorial is 1. And 1 plus 1 is 2. And so that's also a match. And so our final answer would be the Laplace inverse of fs is equal to, so the first one is 2 times 1 divided by s minus 1, so this right here, and that would produce 2 times e raised to t, because a is simply 1, minus, because we have a minus in the front, we have t times e raised to t because of this. So n is 1, so t raised to 1, and a is also 1, so 1 times t. And so this right here is our final answer, and that's all we need to do.